Here we're looking at just some of the other notations for derivatives. This first one is just saying f prime of x because it has that dash mark that we've been seeing. All of these, again, by the way, are equivalent to one another. They're just different ways of saying derivatives. This one right here represents y prime. This one is saying the derivative of y with respect to x. This is saying the derivative of the function with respect to x. And then finally, the last one is saying the derivative of f of x with respect to x. So again, all of these actually represent the same exact thing. They're just shown in different ways. Now, when we're looking at example 1, these are all cases where they are not differentiable. And pretty much what that means is if you were to at least try to take the tangent slope to this point A, well, it's incredibly difficult to do that because we're not 100% sure where that derivative is, whether it be over there or over here. Notice that we have that jump in discontinuity, and that's really the reason why it's not differentiable. So this one would be considered a jump in discontinuity. And so that's why it's not differentiable. For the next one, we see that we have a vertical asymptote. And the reason for why this is not differentiable is because you're figuring out a tangent slope, you're figuring out another tangent slope, you're figuring out another tangent slope as you get closer and closer to this A value. But you'll never quite reach a tangent slope because then all of a sudden it's like, well, where are those tangent slopes maxing out at? And then all of a sudden they shoot back down here. So because of that vertical asymptote, you can't actually take the tangent slope at those particular values, and this would again be because of the vertical asymptote. Moving on, we notice that for this third one, we're seeing what's called a cusp at A, and the reason why, the reason why this doesn't work is if you were to try and take a tangent slope, just for example, like this would be a tangent slope. Right here, that would be another tangent slope. If you were to try and take the tangent slope at this cusp, well, for all we know, it might be right here. Our tangent slope could also be this. It could also be this. And so we're not really definitively sure which is the true correct tangent slope. And unfortunately, as a result, you just can't do a derivative specifically at a cusp. Or I'm sorry, you can't find the tangent slope at a cusp. So the reason why this is not differentiable is because there's a cusp there. It's also known to be referenced as a kink. So if you hear or see that somewhere, that's another one. This last one, there is in fact a vertical tangent line. And it is defined here, but again, what's going on here is you're trying to figure out what are these tangent slopes. And as you get closer and closer to that A value, your derivative is going to go toward infinity. And as a result, you really can't, it's not differentiable as a result of that. So that would be the reason why this last guy is not differentiable, because you would literally have a tangent slope that goes to infinity. All right. So again, though, that is example 1 from our 2.2 number 3 set of notes.